this lab, I used a magnetometer app and a bar magnet to experimentally calculate the magnetic moment of the bar magnet. I found this to be 4.007 Newton meters per Tesla. I also experimentally determined the net magnetic field components along a 45-degree angle. Then I compared these values to the results calculated by the computational model I created in Glowscript. I found that the values were fairly different. These were the two main equations that I used in this lab. I used the first one to calculate the magnetic field in the computational model. I used the second equation to model the relationship between the magnetic field of the bar magnet, a proportionality constant, and the distance between the bar magnet. Finally, I used the principle of superposition to understand the net magnetic field as a sum of the magnetic fields of components in the system, in this case the Earth and the bar magnet. I set up my phone based on where the x component of magnetic field measured by the magnetometer was close to 0 and the net magnetic field was close to that of my geographic location. Then I repeatedly measured the distance between the sensor and the bar magnet at specific net magnetic field values. For the second part of the lab, I found the distance from the sensor to the bar magnet with the net magnetic field at 100 microtesla and the x, y, and z values of the magnetic field at this point. I found that the magnetometer would be close to 0 in the x direction when the bar magnet was far away. I also found that the x component of the net magnetic field increased when the bar magnet was close to the sensor. I added my data to Excel, which averaged 3 measurements of distance from the bar magnet to the sensor when the net magnetic field was close to 2070, 120, 170, and 220 microtesla, respectively. This graph on the right shows the results. The equation, which follows the format below, is meant to model the trend of the data as best as possible. However, it is easy to tell that my data does not fit this line well. This is most likely due to errors in measurement. I found it hard to accurately measure the distances and identify the correct x component value of the magnetic field as the numbers changed frequently. I noticed that my data mostly plotted linearly until I added my data for a net magnetic field around 220 microtesla. So I repeated this one 9 times. However, I still ended up with a weird graph. Using this equation, n is determined to be negative 2.0215 and ln of k is negative 14.037. The value for n is significantly different from what it should be, negative 3, which is most likely due to the error described above. For the off-axis field along a 45-degree angle, these were the measurements I collected on the left, their averages, and the calculations for the correct magnetic fields in the y and z directions as well. To calculate the dipole moment, I used this value for k in this equation and solved for the unknown. These are screenshots of the important parts of the computational model I made in Glowscript. First, the top image shows the function for calculating the magnetic field for a dipole using the equation mentioned previously. The image below shows how I use that function and the position vector from the magnet to the observation point to create arrows for the direction of the magnetic field created by the magnet at different locations. I repeated this part multiple times for different observation locations. The last image shows the code I used to create an arrow for the direction of the magnetic field along 45 degrees. These are the results of the model. The picture to the right shows the distribution of the directions of the bar magnet's magnetic field at different points. The image to the left shows the numerical results. Here you can notice the calculated magnetic field at 45 degrees is kind of close in the x component, but very different in the y component to the experimentally calculated values. This could be due to the inaccuracy in measurements or potential interference from nearby objects. If I did not compensate for the Earth's magnetic field in my setup, then my measurements for the magnetic field at different points would be different because they would, by the principle of superposition, factor in the Earth's magnetic field as well, not just the bar magnets. This would mean that my calculation for the magnetic dipole would also be off. If I used 2 identical magnets stuck together, the net magnetic field would have double the magnitude, but the direction would not change because the 2 magnets would still orient such that the magnetic field would run north to south.